Hello, everybody! All right, in this video, I'm going to teach you guys how to use the Pythagorean Theorem to find the missing side of a right triangle. But this is part 2, so make sure you've already watched part 1. Once again, this is the formula for the Pythagorean Theorem, a squared plus b squared equals c squared, and you can only use it for right triangles. All right, let's look at this first example. As you can see, this triangle is kind of rotated around. So the key thing to know where your hypotenuse would be, find that right angle. And whatever side is directly opposite of it is considered your hypotenuse. So 16 is what I will label as C. And then, like I said in the previous video, you can label your legs of A and B in any order that you choose. So my A is X, my B is 4, and my C is 16. And I'm going to go ahead and plug in these for A, B, and C in the Pythagorean Theorem formula. And that will give me X squared plus 4 squared equals 16 squared. Now, I'm going to go through and evaluate the values that I can. 4 squared equals 16. But I'll just bring down my X squared. And then 16 squared equals 256. All right, now my goal is to get X by itself. So the first thing I have to do is get rid of that 16 that's on the left side. Since it says plus 16, I'm going to do the inverse operation, which is to subtract 16. So I'm going to subtract 16 on both sides. And 256 minus 16 gives me 240. And I'll just bring down my X squared. Now, I have to get rid of my exponent of 2. The only way I can get rid of the exponent of 2 is by taking the square root. Since I take the square root of the left side, I must take the square root of the right side. So that will cancel out the exponent of 2, and I'll just bring down my X. But guess what? 240 is not a perfect square. So what do we have to do? We have to go over to the side and break it down like I teach you guys in class. So you can use whatever values you want, but I'm going to break this down into multiples of 24 times 10. And since I broke it down, I got to scratch this out. 24, once again, you can use any numbers of your choice. I'm going to use 6 times 4. And since I broke it down, I can scratch this out. And then for 6, I'll use 3 times 2. Since I broke it down, I'm going to scratch this out. And 4, I'm going to use 2 times 2. And since I broke it down, I'm going to scratch this out. 10 will be 5 times 2. Since I broke it down, I'm going to scratch this out. Now, I'm going to go through and do the tree I taught you guys in class. For every pair, you take 1 out. For every pair, you take 1 out. So I'm going to go through and ask myself, do I see a pair of anything? Yep, I see a pair of 2s right here. So I'm going to take 1 of them out. So these are gone. And then I'm going to ask myself, do I see any more pairs? Yep, I surely do. I see a pair of 2s right here. So I'm going to take 1 of them out. So these are gone. Do I see any more pairs? No, but I do have a leftover of a 3 and a 5. So I'm going to multiply them. 3 times 5 gives me 15, and that will stay under the square root. Since I took out a 2 and a 2, I'll multiply those, and it'll give me 4, and that will go outside in front of the square root. So my missing side will be 4 square root of 15. And that's it.